Hello year 8 and welcome back to mathematics. In today's lesson we're continuing with our topic of measurement and we're going to be looking at area again. In this lesson in particular we're talking about the area of sectors and composite shapes. So for today's learning intention we want to find the area of sectors and composite shapes, and we want to be able to identify what a sector is and the formula for the area of a sector. Apply the area formula to find areas of sectors and also find the area of composite shapes involving sectors. So let's get started in today's lesson. First thing we need to talk about is what a sector is. Now here's a quick definition for what a sector is. A sector is a part of a circle enclosed by two radii. So I'm going to just highlight a few key phrases here. Enclosed by two radii of a circle and their arc. So two radii of a circle and the arc. Now, what this looks like is if I draw on two radii on my circle here, so let's say I draw on this one radii over here, so that's one radius. So two radii is just a plural of two radiuses, so that's just a plural of radius. So if I draw one radius here and one radius here, that's a two radii, and the arc is just the curved line between them. So this area over here, this shape that we have between my red lines, that is my sector. And so here this following line says, this is a pie-shaped part of this circle. So if you have a look at it, it kind of looks like we've taken this chunk or this pie shape out of my circle. And so here, this guy here is my sector. Okay, now what we want to be able to do is find the area of the sector. Now, the way that we do this is, well, if you have a look, the sector is just a part of my circle. It's a fraction of my circle. And so what I'm going to actually use is I'm going to use my area formula. So here, I'm going to need to get the radius of my circle. So my formula is going to involve r. And the other thing I need to actually use is I need to figure out what angle is at the center of my sector. So here, the angle at the center here, I'm going to call this guy theta. So theta is just a Greek letter that we usually use to represent missing angles. And so here, this is the angle at the center of my sector. Now, if you think about it, if you remember from when we looked at angles earlier this year, all angles at a point, they all add up to 360. And so if I want to find just how much of my circle I have here in this sector, all I need to do is take my angle theta and divide it by, well, the total angle around. So the whole angle of a revolution, that's 360 degrees. And so all I need to do, if I want to find the area of my sector, is I take my little angle theta. I'm going to erase this because I don't really need that part here. I'm going to take theta and I'm going to divide it by 360 because that will tell me how much of my circle I have as part of my sector. And I'm going to times that by pi r squared. Now pi r squared, hopefully this is very familiar to you guys. This is what we've been looking at over the last lesson with the area of a circle. So this is the area of circle. And this part over here, this part here is just what fraction of the circle we have, well, the sector makes up. So what we need to do is we need to find what fraction of the whole circle that this sector makes up, and then we times it by the area of a circle. So that's the formula we're going to be using when we're trying to find the area of a sector. Theta over 360 times pi r squared. So let's have a go with a couple of examples of this. Now, when we're trying to use this formula, what we need to do, a few steps here. So firstly, just like we did in the previous other examples, first step we want to do is just to write this area formula, theta over 360 pi r squared. Then we want to find the angle at the center of my circle. So here, we just want to find what is the angle inside my sector here. And then write this as a fraction out of 360, and then we multiply that fraction by the area of the full circle. That's what we're going to be doing in these examples. So let's have a go at a couple of examples here. Find the area of the following sectors, correct to two decimal places. So here we're going to need is our calculators, because if you have a look at my formula, I've got this pi. I don't know what pi, I don't have an exact value of pi that I'm going to be able to use, so I need to actually use my calculator for that. So here, let's have a go at this first example. I've got this sector here, and we've got the information that we get given is that it's 2 centimeters here, and we've got 120 degrees in the center. So what I'm going to do, I'm going to write down my formula. A is equal to theta over 360 pi r squared. Okay. So from here, what we need to do is we need to substitute figure out our values that we put here. So theta is just the angle in the center of my circle, which just happens to be this 120 degrees. So I'm going to write here 120 over 360 times pi times, and r is just the radius of my circle. So here, if you have a look at this shape, the radius is just going to be that 2 centimeters. So I'm going to times that by 2 squared. Okay, we can chuck this in a calculator and help us figure that out what that is. So here I'm going to go, okay, I've got 120 over 360. So that's the fraction of my circle that I have in my sector here. So that's telling me I've got 120 degrees out of the full 360 times by pi times 2 squared. And so we get 4.188, and we want this to 2 decimal places. So we're going to get 4.19. So here, this is 4.19, and we need a few units for this. This is the measurement that we have is in centimeters. So this is going to be in centimeters squared because we're dealing with area once again. Okay, so quick recap here. We're going to use this formula, theta over 360 times pi r squared, and we're going to substitute our values in. So we need to figure out what theta is, the angle at the center of my circle, and I'm also going to need to find what the radius of my circle is. Okay, let's have a look at the next example. Now, part B. We've also got this other sector here. So it's actually got the whole, here for this sector, we've actually got the bigger part of the circle. So this is like imagining someone took a massive chunk of pie, or it kind of looks a bit like Pac-Man. And here, if you have a look, we get given that the radius is 5 meters, which is great. And the angle that we get given is this one over here of 70 degrees. Now, when we're trying to find the area of a sector, let's write our formula. A is equal to theta over 360 pi r squared. Now, theta, I said, was the angle inside our sector. But if you have a look at this angle over here, this 70 degrees, this is on the outside of my, it's on the outside of my sector. It's not actually inside. What I want to actually find is I want to find this angle over here. Well, if you get given the other angle, the way that we can find our theta is we can go, well, the angles in this of a revolution, so at this particular point, they add up to 360 degrees. So if I want to find the blue angle, all I need to do is I take 360 and I subtract 70 degrees. Because I know that this part is 70, and I just want to find the angle that adds up to give me 360. And that will actually be the angle inside my sector. So here, this is actually 290 degrees. And so here, just be really careful. Be really careful. Here, even though they've given us 70 degrees, that's not the angle inside my sector. And so in order for me to actually answer this question, I need to find that angle inside my sector first. So in order to find this angle here, I need to actually go 360 degrees minus 70, because that's just the angles of a revolution. Okay, so here I can put that in. I've got 290 over 360 times pi times the radius was 5 and we square it. And so we can chuck this in our calculator. So here I'm going to write 290 over 3, I keep bumping my screen, 360 times pi times 5 squared, and so we get 63.268, and you round that to decimal places, that becomes 63.27. And here we just need to chuck a unit at the end. The measurement was in meters, so I'm going to have this in meters squared. Okay, so that's how we find the area of a sector. We want to find out how much of what fraction of my circle each one of my sectors takes up. And so the way we do this is we take the angle inside my sector. And so here, the angle inside my sector for the first one was 120. And the angle inside my sector for the second one was actually 290. And we actually had to do an extra step to find that. So after I've done that pi over 360, I just multiply that by the area of my circle. So what I normally would have done in our last lesson. So here that was just pi r squared. So that's how we can find the area of a sector. Now, the other part of today's lesson, we actually want to look at finding the area of composite shapes using the area of sectors. Now, early in this topic, we already talked about composite shapes. If you remember, composite shapes were shapes where you took two basic shapes and you either added them together or you subtracted them from each other. And so we had a look at an example where we found the area of a shape where you had a rectangle and you subtracted a triangle from it. So here. And we also had a look at an example where we had a square and we added on a little rectangle on the side and we found the areas of those. And so the way that we did this, if you remember, the first step that we did was we identified what shapes make up the composite shape and how it was made. So were the two shapes being added together? So for example, in the second example over here, we had two shapes that we added together. Or in the first example, we actually had to subtract two shapes together. Then what we did was we found the area of each of those shapes and then we applied the correct operation identified in step 1. So here for the once we found those two areas, we either added them together or then we subtracted them. So we're going to do the same thing here, but with sectors as well. So let's have a look at this example underneath. Example 2, find the area of composite shape. So find the area of this composite shape correct to 1 decimal place. So here we've got a shape, the one in the blue lines here. So here, this shape here. And as you know, if you have a look here, it's actually made up of two shapes. What two shapes can you guys see here? Well, when I'm looking at this, actually, there's the two shapes that I see is, first of all, I see a big rectangle. So I see the big rectangle here in the pink lines. And then the other shape that I see is actually they've taken out what kind of looks like a quadrant or a quarter of a circle. And so here, the way I can find the area of this shape is I can go, okay, the area is going to be the area of my rectangle minus the area of my green part was my sector. It's actually a sector here as well. And so I can find the area of both those shapes. Oh yeah, before I can move on. What we've actually done here, in order to get the shape, that blue line shape, well, what we did was we took the area of the rectangle, and then from that, we got rid of this quadrant or this sector here. So we take away that sector and then we're left with just this part over here, which is what the area that we want to find. And so that's why we are going to be subtracting the two. Okay, now, this is where you need to actually think back a couple lessons. We need to first figure out what the area formula for a rectangle is. Now, if you remember a couple of lessons ago, the area formula for a rectangle was L times B. And just as we looked at today in today's lesson, this shape here is a sector, and the way that we find the area of a sector is we use theta over 360 times pi r squared. Okay, so now that we've done that, we need to find the parts in these formulas. So let's start off with the rectangle. We need to find L and B. Now, L and B are the length and the breadth of the rectangle. So if you have a look at the shapes, well, we've got 20 millimeters and 10 millimeters. So those are going to be my two measurements for my rectangle. So here I'm going to have, that's 20 times, oh, let me move this down a bit. For my rectangle, to find the area of that, I was 20 times 10. Okay, cool. And then from there, I'm going to need to subtract the area of my sector. Now for my sector, I'm just going to unhighlight that. If I have a look at that green part here, what we want to first do is figure out what the area what this angle at the center of my sector is. And if you have a look here, they've given me this little box in the bottom right, which means it's a right angle or 90 degrees. So here it's going to be 90 over 360 times pi times, and the second thing I need to do is find the radius. Now if you have a look, the radius is going to be this length over here. Now if you have a look at my diagram, I don't know what that length is. But the other thing is I also know that this length here is also my radius, and I actually know that measurement. If I have a look at the diagram, this measurement over here, that's the same as 10 millimeters. And so my radius is just going to be 10 millimeters. So here's going to be 10 squared. Okay, and this is in the measurements are in millimeters, so this is going to be in millimeters squared. So I can chuck this in my calculator. I can go 20. Let me try that again. 20 times 10 minus 90 over 360. And we're going to, move this over here and move it up a bit. There we go. 90 over 360 times by pi times 10 squared. And so we get 121.46. And so that's, and we want this to one decimal place. So this just becomes 121.5 millimeters squared. And so here, just like we found an area of composite shapes before, what we want to do is identify what shapes make up our composite shape. In this case, it was a rectangle and a sector. And then what we had to do is we had to actually subtract the two areas together, because if you have a look at the shape that we got given, well, we had my rectangle, and then we had to subtract the sector. And so we had to find the areas of each of those parts and then subtracted it. Okay, so that's it for today's lesson. Let's just do a quick recap of what we talked about today. In today's lesson, we talked about what sectors were. So sectors is a part of a circle where you have two radii, or two radiuses, and the arc between them. And so when we want to find the area of a sector, what we had to do was we had to find the angle at the center of my sector, divide that by 360, and then times that by pi r squared. So find what fraction of the circle we have, and then find the area of a circle, and then multiply the two together. So we went through a few examples of finding the area of sectors, and we also applied it to have a look at finding the composite shapes using sectors. So that's it for today's lesson, Year 8. Hopefully that was helpful, and if you have any questions, feel free to send me a message via Google Classroom or via email. I'm more than happy to try and help you. But until the next lesson, I hope you guys are staying safe wherever you are, and I'll see you in the next video.